bottlenecks in transportation and storage. This slide is to remind you the overall let's say law that the lower bulk density means more problems in the transportation and storage. From the practical point of view, it can happen, for example, when in the beginning of the biomass feeding on the let's say feeder grade, but also you can see this picture from our laboratory scale equipment. If the particle size are too small, if the bulk density is not proper comparing to the transportation system, we can block the screw feeder. As you can see, this feeder is connected with the rotary kiln reactor. For sure, according to our experience, we did not detect any problems with the pellets if we use such a transportation system. But for smaller particles, it is possible to block the screw feeder. And of course, it can happen in the transportation system in the power plant. Another bottleneck or challenge is the problem of self-ignition of wet biomass, especially if we use, let's say, long-term storage in open air, and we have not protection against the atmospheric falls like rains. In such a situation, the probability of self-ignition is very high. You can see the pictures from our country. This is it really happened in Strzeżów, Poland. From our experience point of view, in the beginning, it looks like in the first stage, it looks like evaporation, like biomass drying, but after the minutes, we notice that it is not like that. It is initiation of devolatilization process. Volatiles are released, and the next step, especially if the wind is strong, we can observe the flames of the devolatilized compounds. Of course, we have to react about that. So the first step, as you can see, was to use the water stream to catch the fire, but it is not end on the story, because if we leave it like that without any action, we can again obtain self ignition. So we have to remove the bigger volume and divide it into the few smaller volumes of the biomass. Now you can see description of the about the ability of ignition and explosion, especially if we consider the explosions. We just have to say about the crucial parameters. What influence on the dust explosion, or what increase the probability of dust explosion? The first is the let's say the biomass properties, especially the type and size of particles. It can be also coal, but today we consider the biomass. The crucial is the moisture content, ash content, and volatile matter content. Another crucial parameters are related with the concentration of the biomass in air. If we consider the dust cloud, so we have the volume of the cloud and the mass of the biomass included in the cloud. So we have such a point where the concentration of the mass of the particle inside is enough to initiate the explosion. Also, the crucial point is the oxygen concentration, because if we apply some inert atmosphere, if we add more nitrogen, for example, to the meal atmosphere, we decrease, in fact, the probability of explosion. If we have some regions at the higher air concentration, for example, especially if we use the air as the oxygen as processing agent, let's consider oxy-fuel combustion, we also have some increased probability of dust explosion. Another crucial parameter is the temperature. The temperature of gases, they surround the particles, the dust, and of course the surfaces when the dust can be settled down. So this temperature is very important. Of course, the obvious phenomena, the higher temperature of the gas and surfaces means that the probability of the ignition or explosion is higher. And the last important and crucial parameter in terms of dust explosion is area. So we consider the open area and closed area. For closed area, for example, the vessels, chambers like mill, room, the consequences of explosion are much more serious comparing to the explosion in the open area, because of increase of the pressure of pressure of explosion. And also in literature we can find some parameters. They identify the explosion characteristics. The most important are the deflagration index, the maximum explosion pressure, the minimum explosion concentration. So it is rated with this one parameter, and the minimum ignition energy. The crucial parameter if we consider the initiation of explosion from the sparks, and the temperature, as we already explained. There are examples of such parameters, but we also have some experience or the results from our institute, the different from the coal, the different from the biomass, but more important is what is the impact of a specific parameter on the dust explosions factors. So as I said, we consider the minimum explosion concentration, the minimum ignition energy, as I said, for example, from spark, the minimum ignition temperature, the maximum explosion pressure, and the explosion index. So let's consider the few parameters: the particle size, the dust concentration, oxygen concentration, combustible agent. It can be methane, it can be carbon monoxide, solid inert concentration, and the moisture. So, for example, let me explain it this one. We consider like that. If we have the bigger particles, so the minimum ignition energy is higher. What does it mean? That means that if we have very thin, very small particles, so the low energy spark is enough to initiate ignition. So in fact, the lower particle size means the higher probability of explosion. If we consider the dust concentration, so we can see that, for example, the minimum energy of ignition increase and decrease again. For example, for moisture and for solid inertant concentration, we increase the minimum explosion concentration. What does it mean? That more moisture and more inertant particles inside means the less explosion probability. And this is a description about the dust explosion areas in the power plant. We consider the such chains like choppers, wagon tipplers, fuel bunkers, fuel storage tanks, everywhere where the biomass is collected, is stored, and is processed. So this is for your imagination. We can distinguish between the different places in the transportation and storage when the biomass, the explosion can be initiated in the process, in the biomass processing. This picture shows some
Janusz, can I have some question to you? How often it happens? Is it frequent? It never happens. You know, you're showing the.
No, if I remember, we show it on the first webinar. It depends on the safety system. It can happen a few times per year. If you remember, we present some chart with the some accidents with explosions and fires. So it depends on the safety system. If the safety system is applied, sometimes it doesn't happen. But if we have not some specific safety system, it can happen a few times per year, even
in one location, in one power plant. So it can be multiple exactly. Explosions over the country if the program is implemented broadly. Okay, okay. Thank you for this. You know, most probably there are some people which were not able to see the first webinar, so maybe. It would be good to explain this issue to them. Thank you.
Exactly. So you can see examples of the picture from the industry where the dusting can occur, mainly in the transportation side, but also in some preparation system. You can see here the whole of the coal processing just before feeding to the milling, but also as we said, it can happen in some due to impact of surfaces. You can see the electric engine, electric devices here when the dust layer is collected on the surface. So it can be also the place where the fire or explosion can be initiated. If we consider the way of the dust explosion or another, say, the mechanism of the dust explosion, so the first reason can be the hot surfaces. If we consider especially the mill, it can be the mill balls or mill bowl, but also the reason can be hot gases that influence on the particles cloud. Another reason or the way of dust explosion is to enhance the volatilization. As you know, the volatile content in biomass is much more higher comparing to the coal. So if the volatilization process is enhanced, the probability of explosion is also increased, and it can happen especially when the mill is inert by steam. This is the process well known for engineers, but let me explain it very shortly. There are no some very specific time of the mill processing, especially if we want to remove the period from the chamber, from the specific chamber. Very often the mill is the steam, the hot steam is introduced into the mill. So it's in such situation the devolatilization process of the biomass can be enhanced. And the last one is the sparks, is electrostatic discharge, and this process is strongly related with already shown parameter, the minimum ignition energy.